Okay, so here we have a particle moving in a straight line. It's got a certain acceleration. When t is 0, the particle is located 2 meters to the... Stop right there. Remember when we said, if it just gives you weird information like that, probably means you're going to have to integrate. Okay, so let's just make a note of that. T equals 0, the particle is located 2 meters to the left. When t equals 2, it is 20 meters. Oh, so we got two sets. Okay. Determine the position of the particle when t equals 4 seconds. Okay. So our goal is to find the position of the particle. So S, S at t equals 4. Okay, so we're going to need some kind of an equation. We're going to need a function for S. Okay, now what we've got is a function for A. Okay, so let's just jump into it and see what we can do. We'll use our relationships. So A is dv dt. Okay, and so that means our V, if we rearrange this a little bit, dv is a dt. We'll integrate both sides. Okay. Now we actually don't know anything about V0. Okay. So what we did last time in the last video when we had this kind of thing is, remember we knew something here and we knew something here and it helped us out. In this case, we got nothing. Okay. We got nothing. So that means we have to leave both of these as indefinite integrals. Okay, so we're going to have here, we're going to have V, and we're going to be integrating 4 t squared minus 2 dt. Okay, and so that's going to become 4/3 t cubed minus 2t plus c. There we go. Okay. All right. So now we're going to do it all over again. Okay. And so we're going to say here that we've got V is I'll use S. ds dt. So if we rearrange that, we're going to have ds is V dt. Integrate both of these. Okay. Now this time we do have some information, but you know what? Because we already have a constant in here like this that we're going to have to deal with, I don't think there's any advantage necessarily to plugging in our endpoint numbers. All right. I don't think it's going to save us much, if anything at all. So let's just sort of leave it like that. And so that means we're going to have here that S is the integral of 4/3 t cubed minus 2t plus c dt. Okay. All right. Now, so we'll go ahead and integrate that thing. Okay. So we're going to have 4, and that's going to become a 12 on the bottom there, t to the 4th minus t squared plus ct plus c. Okay, no, that sucks. Okay, so we've got two. We can't have two c's in. I mean, they can't be the same, right? So what we really need to do is we need to make sure. Let's call this C1, which means that that was C1 and that's C1, and we'll call this C2, just like that. Okay. All right, so there's our function. It's got these arbitrary constants, C1 and C2 in there, and we got to figure out what the values of those are. That way we can come back over here and plug it in to our function and figure out what we're dealing with. Okay, so let's just start with the first condition. T equals 0, the particle's at 2. Okay, so we're going to say here S t equals 0 has to be equal to 2. And it's to the left of the origin, so it's actually minus 2. Okay, like that. So 4/12 becomes 1/3 0 to the 4th power minus 0 squared plus C1 times 0 plus C2. Aha! Well, that's pretty nifty. We can see right there that C2 is -2. Cool. All right, now we're going to use our other condition. S at t equal to 2 seconds is -20. Okay, so it's 20 to the left right there that we can see. Okay, so we're going to have 1/3 2 to the 4th power minus 2 squared plus C1 times 2 minus 2. Okay, because we're going to plug in right there for C2. That's how we're getting that term right there. Okay. All right, so then we just have to plug that in, solve that thing, and we're going to see then that C2, C1, turns out to be, well, this is not a fun number, 9.67. Okay, negative 9.67. All right. Now let's talk about units for just a quick second here. C2 is going to have units of meters. Okay, because my whole equation up here is meters. Okay, on the other hand, C1, the units on that way, it's times seconds. So C1 is really like a speed term. So that means this guy is actually meters per second. Okay, if we needed to know that information there. Alrighty, so let's come back all the way over here. So S evaluated t equals 4. Okay, what we're going to have is 1/3 t to the 4th power, and we're putting 4 in there, minus t squared minus 9.67 t minus 2. Okay, and when we get all that done, we learned that S is 28.7 meters. Okay, there we go. So pretty straightforward. Now, every time you do an integration, you expect to get like a plus C term or something like that. So you've got to have some what's called initial conditions or boundary conditions. Both those terms mean the same sort of thing. Okay, and whenever you run into that, what that means is you got to deal with something like this and something like this. So we have two boundary conditions given to us, or two initial conditions given to us. That means we can expect to have to do two integrations. Okay, if we did two integrations and they didn't give us two sets of initial conditions, then we'd be stuck with this form right here, and we couldn't get an actual number for our answer. We would just have a weird sort of algebraic expression with C1 and C2. All right, anyway. So there you go. You'll learn more, like I said, more about integration by parts later on, okay?